Hello everybody. So today we are going to go on to section 5 and we're going to take a look at how to use what we've been seeing so far with the Z-score tables in real life, or at least take a look at some problems that we would encounter in real life and how we can use what we've seen so far to solve them. Okay, so let's take a look. First example, a light bulb manufacturer produces 3,000 or 35,000 bulbs. From previous data, the company has discovered that the lifetime of the bulbs they produce is normally distributed. Important. With a mean lifetime of 900 hours, with a standard distribution, I should say standard deviation, of 50 hours. Predict what percentage of bulbs will last between 825 and 875 hours. Okay, so if we have a mean of 900 here, that's right in the middle, right? And we want to know what percentage of the bulbs will last between 825, so something like this, and 875, something like that. So this is going to be 25, this is going to be 875, and what we want to do is we want to predict what percentage of them are going to end up here in this range. So what they're asking us for is, well, what percent of the area under the curve is here, right? Okay, so we want to find the z-score for these two. So we want to find z1, we want to find z2. So we can go and we can use the z-score table to find the area there. Okay, well, that means that we're going to have to use our z-score formula for both of these. So for z1, that's going to be x1 minus the mean divided by the standard deviation. And for the z-score of the second one, that's going to be the data point of the second one minus the mean divided by the standard deviation. Okay, so we have the mean, it's 900 from the question. We have the standard deviation, it's 50 hours from the question. So this x1 and x2, those are the data points. Okay, so what was the data that this company was gathering on its products? It was gathering lifetime. How many hours before the bulbs burn out? Okay, so that means any x value we get has to be talking, or sorry, any x value that we use, that we decide to use, has to be involving the lifetime of these bulbs. It has to be discussing some duration, right? So what we're going to be using for x1 and x2 here are going to be these two values, 825 hours for the first one and 875 hours for the second one. This is going to be x1, this is going to be x2. Okay, so we want to find the z-score of x1 and x2 so we can use the z-score table to find this area. All right, so we'll come down here, make our substitutions. This is going to be 825 minus 900 divided by 50. This is going to be 875 minus 900 divided by 50. Of course, both of these numbers are going to be negative. Makes sense because it's to the left of the average, right? Okay, so here we'll come over and so we'll do 825 minus 900. Obviously, well, I guess I don't really need to be using a calculator for this, but I did anyway. This is going to be negative 1.5. Then this is going to be what? Negative 25. So it's going to be negative 0.5. Okay, so we got the two z-scores there. But that's not what the question's asking. Of course, the question is asking how many, what percentage of their bulbs that they make is going to last between those two values. So we're going to have to go to our z-score table. So we'll say from table. All right, so we need negative 1.5. So let's see. Negative 1.50 is right here, right? So it's going to be 6.68%. And then negative 0.5 is right there, so it's going to be 30.85%. Okay, so remember, when we're using the z-score tables, they are describing the area under the curve to the left only, okay? So what we want to do is we want to take this value and subtract from it this value, right? Because 30.85% tells us everything from here to the left. And we don't want this part, right? We don't want that white part, we only want the green part. So we need to take that, which is the 30.85, we want to subtract that, which is the 6.68. So what we have left is only the green part. Okay, so we'll come in, 30.85 minus 6.68%. That's going to give us 24.23% of that company's bulbs are going to last between 825 and 875 hours. How many of the 35,000 bulbs would we expect to last? Well, if it's 24.23%, all we got to do is take that 35,000, multiply it by 24.23%, and definitely gonna need a calculator for that one. So we'll do 35,000 times 0.2423. Whoops, didn't put that in properly. 35,000 times 0.2423. So it gives us a decimal number. We'll round it to the nearest whole number. So it's going to be 8,481 bulbs. Will last between 825 and 875. Okay. So we didn't really do anything new here, right? I mean, we used like it's in a word problem now, but at the heart of the question, we're just doing what we did last week, right? We're finding our two z-scores. We're looking up the corresponding area for those z-scores, and then doing whatever math we need to do in order to get the values we're looking for. In this example, we had to subtract them. Okay. What's the probability that a randomly selected bulb will have a lifespan of 920 hours or less? Okay, so now we have our curve. And as we know, the mean is 900. So 920 is going to be over here somewhere, right? And if it's asking for a lifespan of 920 or less, that's going to be from here over, right? So now, of course, we're going to be interested in this area. Okay. So of course, we're going to want to find out our z-score for that one, because remember, the area under the curve also represents the probability of randomly selecting that value. Okay, so we're looking for our z-score here. So in this case, our data point is 920. We're looking for the z-score of 920. So it's going to be that one. What was our average? Our average was 900 and our standard deviation was 50. Okay, so that's going to be a positive value because we're to the right. So that's going to end up being 2/5, which is 0.4. That should work out to be. Okay. So we need to go to our z-score table. 0.4, we're going to have to go to the positive values here. 0.4 right there. Okay, so that's going to be 65.54%. So there's a 65.54% chance that any bulb that they pick out of those $35,000 they made, or the 35,000 bulbs they made, any one they pick, there's a 65.54% chance that that bulb is going to live for 920 hours or less. Okay. Let's see. Do I want to do these questions? Sure. I'll do this question, and maybe I'll leave this question for you guys to do next week. Or I'll do it with you next week. Okay. Next example. A study found that mean duration of a certain influenza virus is 12 days with a standard deviation of 3 days. Assuming that this data is normally distributed, so we get that nice bell curve. If you caught this strain of the virus, what's the probability to the nearest hundredth that you would be sick for longer than 17 days and B between 13 and 15 days? Okay, so the mean is 12 days. So that means here it's 12. That means here is 12. Okay, longer than 17 days. Wow, if the mean is 12, the chances of you being sick for longer than 17 is pretty low. So that's going to be over here somewhere. That's 17. And if it's longer than 17, that means we are going to be interested in this side, this area here, right? Okay. So we need our z-score, as always. X minus x bar divided by the standard deviation. So in this case, our data point that we're finding the z-score of is 17. The mean is 12, and they said it was 3 for the standard deviation. 3. So 17 minus 12 is 5. 5 divided by 3. 1.67. Right? So we'll go find 1.67. So 1.67 is here. So 95.25. But remember, that's to the left. Always the z-score table. It gives us the area to the left, but we're interested in the area to the right. So because 100% of the data has to be underneath the curve, if we want to find the other side, all we have to do is subtract 100, or subtract 95.25 from 100. We did that during the last section, so of course that's going to give us, oops, so you have a 4.75% chance to be sick for longer than 17 days. And it makes sense, right? Like we said, if the mean duration of the sickness is 12, the chances of you being sick for more than 17, we would expect that to be quite low, right? Okay, let's do the next one. Sick between 13 and 15 days. So that's 12. 13 is, probably going to be here somewhere. 15 probably going to be there somewhere. And now we are interested, of course, in this area right here. Two values. Okay, so we got two values, which means we're going to be looking for two z-scores. So I'll call this z-score 1, I'll call this one z-score 2. Right? So, as always, same old formula. It's going to be x1 minus the average divided by the standard deviation. And for z2, of course, it's going to be x2 minus the same mean divided by the same standard deviation. All right, so our data points for the z-score we're trying to find is 13 for this one. Right, minus 12 divided by 3. And for this one, this is 15 minus 12 divided by 3. So that's going to be 0.33. And then, of course, this one is just going to be 1. Okay, so from the table, we need to go take a look. A z-score of 0.33 is right there, so that's 62.93%. And a value of 1 is 84.13%. Alright, and if we want to find the area between them, well, we just subtract them, very similar to what we did for this question here, right? So we'll take the bigger number, subtract from it the smaller number. Okay, and I'll just grab my calculator here, make sure I don't make any mistakes. So we get 21.2%. So there's a 21.2% chance that you will be sick for between 13 and 15 days. Okay, so I hope it makes sense when I say that we're not doing anything new, especially compared to the last section. We're just kind of now using what we've learned in the last section for some word problems. Okay, so I'm gonna leave it there for you guys. I only want you to do about half the homework, so why don't we go in and say, so we'll get you guys to go up to question 6 for today, or for this week. So page 283 is where it starts. I want you to do questions 1 to 6, and next week we'll do the remaining half. So I really hope you guys are doing okay out there. I know this whole, learning from home thing is kind of hard, but hopefully this is not going to last too much longer, and we'll be able to get back to normal pretty soon. So stay safe out there, and I'll see you guys next week, okay? Bye.